So, good afternoon guys. It's me again, Federica Tigbak. So, our topic is all about OSI, TCP model and encapsulation and decapsulation. So, our I so it in this topic I only see a information in net account. So, let's go for it. So, as OSI, TCP model, encapsulation, and decapsulation. So, what is an OSI model? So, the Open System Interconnection Model, OSI model, is a conceptual model that characterizes and standardizes the communication function of a telecommunication or computing system without regard to its underlying internal structure and technology. Its goal is the interoperability of diverse communication systems with standard communication protocols. The model partitions a communication system into abstraction layers. The original version of the model had 7 layers. So, a layer serves the layer above it and is served by the layer below it. So, for example, the layer that provides error-free communication across a network provides the path needed by application above it, while it calls the next lower layer to send and receive packets that constitute and contents of the path. So, two instances, the same layer are visualized as connected by the horizontal connection in that layer. So, this model is a product by an Open System Interconnection Project at the International Organization for the Standardization of ISO. The purpose of the OSI is to reference model is to guide vendors and developers so digital communication products and software programs they create will interoperate and facilitate clear comparison among communication tools. While some people may argue that the OSI model is the obsolete due to its theoretical nature and less important than the 4 layers of the TCP/IP model, Comar says that it is difficult to read about networking technology today without seeing references to the OSI model and its layer because the model structure helps to frame discussion of the protocol and contrast various technologies. If you can understand the OSI model and its layer, you can also understand which protocol and devices can interoperate with each other when new technologies are developed and explained. So, second is the TCP model. So, what is a TCP model? So, a TCP or IP or the Transmission Control Protocol or Internet Protocol is a set of communication protocols used to interconnect network devices on the internet. So, TCP or IP can also be used as a communication protocol in a private network, an internet or an extranet. So, it is the entire internet protocol set. A set of rules and procedures is commonly referred to as TCP/IP. Two others are included in the set. So, TCP/IP specifies how data is exchanged over the internet by providing to end-to-end communication that identify sorry for that how it should be broken into packets addressed, transmitted, routed, and received at the destination. So the TCP/IP requires little central management, and it's designed to make networks reliable with the ability to recover automatically from the failure of any devices on the network. The two main protocols in the Internet Protocol set serve specific functions. So the TCP defines how application can create, channels of the communication across a network. It also manages how a message is assembled into smaller packets before they are then transmitted over the Ethernet and assembled in the right order at the destination address. IP defines how to address the route each packet to make sure it reaches the right destination. So in each gateway, computer on the network checks this IP address to determine where the forward message So TCP/IP uses the client-server model of communication in which a user or machine a client is provided a service like sending a web page by another computer, a server in the network. Collectively, the TCP/IP set of protocols is classified as stateless, which means each client-server request is considered new because it is unrelated to previous requests. Being stateless frees up network paths so they can be used as continuously. So the transport layer itself, however, is stateful. It transmits a single message and its connection remains in place until all the packets in a message have been received and reassembled at the destination. So we are going to the encapsulation. So what is an encapsulation? Encapsulation is used to describe a process of adding headers and trailers around some data. So this process can be explained with the 4-layer TCP. With TCP/IP model. So with each step describing the role of the layer. For example, here is what happens when you send a mail using the favorite email program. So data encapsulation in the OSI model. So just like with the TCP/IP layers, each OSI layers asks for services from the next lower layer. The lower layer encapsulates the higher layer data between a header. So the data link protocols also add a trailer. While the TCP model uses terms like the segment, packets, and frame to refer to a data packet defined for a particular layer, the OSI model uses the different term protocol data or PDU. So the PDU represents a unit of data with headers and trailers for the particular layer as well as the encapsulated data. Since the OSI model has 7 layers, PDUs are numbered from 1 to 7, with the physical layer being the first one. For example, the term layer 3 PDU refers to the data encapsulated at the network layer of the OSI model. So, encapsulation is configurable on Ethernet and inter-channel interfaces. So, the IEEE 802.1q is the standard protocol for the interconnecting multiple switches and routers and for defining VLAN topologies. So use the encapsulation DOT1Q command is in the sub-interface range configuration mode to apply a VLAN ID to sub-interface. So last for our topic is the decapsulation. So the decapsulation is the process of opening an encapsulated up data that are usually sent in the form of the packets over a communication network. So it can be literally defined as the process of opening a capsule, which in this case refers to the encapsulated or wrapped data. So when the data are sent through the communication network that follows the OSI or the TCP/IP protocol suite, they are usually sent as the discrete packets of the information. While the sending particular data packet layer of the communication models adds a bit of the information to raw data packet for the understanding of the data at each layer of the receiving end of the communication. So the data encapsulation is the process wherein data are transmitted from the upper level to the lower level of the protocol stack, outgoing transmission from one network to another. So each layer consists of a certain amount of information. So the header, and the data. So as it moves down each transport level, the data are packed until they reach the network access layers, so the destination network. So the data decapsulation is simply the reverse of the encapsulation. So this is the when an incoming transmission to be received by the destination computer is unpacked moves up the protocol stack. So the data at the bottom of the layer are packaged several times to ensure security. As they are sent along the transport layer, these data are unpacked until they reach the network application awaiting the data. So the information in the header is used to determine which network the data are to be delivered to. So that's all for now for our topic about OSI, TCP model and decapsulation and encapsulation. So that's all for now. I hope you learn some about of it. So please don't forget to subscribe and thank you.